Okay, here we go again. Physics, and this is Newton's laws number 3. So here we go. Here is yeah, guess what? It's another block, okay? And this block has a mass of 5 kilograms. And there's a rope attached to it. And somebody's pulling this rope up, okay? In fact, just to make this thing a little more real here, let's see what we can do here. Okay, and then here's this person standing here, and they're pulling up on this rope. They're exerting an upward force on the rope, and that force is actually a tension force, so I should make this a T. Tension. That's just the name given to a force. If it's in a rope or a cable or a string or something like that. Right. So they're pulling up on this thing here. So how much force do they need to exert on this object so that it has an acceleration, yeah, of 2 meters per second squared? All right. So F equals ma, net force equals ma. And then what I'm going to do, though, is, oh, yikes, I disappeared the ground. There we go. So, yeah, net force equals ma. But what I'm going to do first is draw all the forces acting on this block right here. This is called a free body diagram. So I've got T, and of course there's gravity, mg. And I'm going to choose up as the positive direction. And then I'm going to write this. I'm going to write net force equals ma. And by now I hope you're figuring out how to fill this part in, okay? In this case, it's going to be, since T is up and mg is down, I'm going to write T minus mg equals ma. And at this point, we can start to fill things in, okay? So for example, the weight of this object here, mg, that's the force of gravity. So it's going to be 5 kilograms. The value of g we're using here is 10 meters per second squared. Remember, it's actually 9.8 meters per second squared, but we're rounding up just to make the numbers nicer. So that weight, 5 times 10 is 50. And a kilogram times a meter per second squared we call a newton. So T minus 50 newtons is equal to ma, mass times acceleration. So the mass of this thing is 5 kilograms. And the acceleration we want to have is 2 meters per second squared. So 5 times 2 meters per second squared. So then we're going to have T minus 50 is equal to, well, 5 times 2 is 10. And the kilogram times a meter per second squared is a newton. So T minus 50 is equal to 10. Gee, so what does that make T? Well, let's see. 60 minus 50 is 10. But if you want the numbers, we can do the numbers. We can do this with the math here. To get T by itself, I'm going to add 50 to both sides. So plus 50 plus 50. So then on the left side, minus 50 plus 50, that goes away. So I've got T is equal to 10 plus 50 is 60 newtons. So, problem done. and I'm listening to the radio. I have no idea who this is playing. So yeah, T is 60 newtons. And that will cause this thing to start to gain speed at a rate of 2 meters per second squared. Okay, next problem. Let's see. Rocket blasting off. There's probably a hamster in this rocket. Okay, so here's a rocket. It's a model rocket. So it has a mass of 2 kilograms. Okay, and so it has this rocket engine inside of it that you ignite, and it spews out hot gas in one direction, and that gas exerts a force in the opposite direction. And that force lifts the rocket up against gravity, and that force is called thrust. So let's say that, I don't know what this thrust is. That's what we're going to try to figure out. How much force does the engine need to exert against gravity? So the other force acting on this rocket is its weight, which is mg. So mg is going to be 2 kilograms times little g is 10 meters per second squared. And so 2 times 10, well, 2 times 10 is 20. And a kilogram times a meter per second squared is called a newton. So the weight of this thing is 20 newtons. All right. And here's the deal. We want this engine to give the rocket an upward acceleration of a whopping 5 meters per second squared. Okay. So how powerful does the engine need to be so the rocket, this 2 kilogram rocket, has an acceleration of 5 meters per second squared? That means it's going to be gaining speed 5 meters per second every second the engine is burning. So I'm going to write Newton's second law, which is net force equals ma. Once again, I'm going to let up be the positive direction. Right. So I'm going to write here thrust minus mg equals ma. Instead of writing out this whole word thrust, you could put like F sub T if you wanted to. It's just less stuff to write down, less stuff, as long as you can remember. I'm just abbreviating this thrust force with an F sub T. So now we could put in some numbers if you want to. So F sub T, that's the thrust force, minus the weight of the rocket. It's 20 newtons. Equals the mass of the rocket times its acceleration. So 2 kilograms times 5 meters per second squared. So now I've got F thrust minus 20 equals 2 times 5 is 10. And a kilogram times a meter per second squared is called a newton. So F sub T minus 20 newtons is equal to 10 newtons. So what number minus 20 is equal to 10? That would be 30. But again, we could do the whole math thing here if you want to. The way to get the F sub T by itself is to add 20 to both sides. So F sub T, I'm going to add 20 here and add 20 here. So negative 20 plus 20, that cancels out. That's the whole point of adding 20 to both sides. So F sub T is equal to 10 newtons plus 20 newtons is 30 newtons. So that rocket needs to exert a thrust force of 30 newtons. And that'll get that rocket with an acceleration of 5 meters per second squared. Okay? And that's good for now. Good, so I'm going to go ahead and save this, and you should practice doing this problem again and again and again. And then you should practice it again, okay? And this will start to sink in. It'll become easy for you, all right? So there you go. All right, y'all have a good night. Gonzo out.